Okay, this is questions 32 and 33 on the final review study guide. So, you're supposed to solve the triangles and they're right triangles, so you can assume that there's a right angle at least somewhere in the triangle, so that's at least one angle already solved, which is 90 degrees. You gotta solve using SOHCAHTOA and then round all sides to the nearest tenth and all angles to the nearest degree. Also, with right triangle, that could mean that you can also solve the lengths with Pythagorean theorem. So, first one, 32, draw a triangle. A, C, B. Let's fill in your givens. Angle A is 41 degrees. Side A is 7.4. And we don't know B. However, we do know C because it's a right triangle. It's 90 degrees. Now, you gotta use law of sines to solve SOHCAHTOA. That's at least how I would do it. So you put the length over the angle, sine angle. So that's length A over angle A. And let's say we're trying to solve for side C. Since we already have a given angle, we can do that. Sine 90, since it's the angle on the bottom, over length C. Now what you do is cross multiply. So they'll do those two and do these two. And then after doing that and rounding to the nearest tenth and nearest degree, length C should be 11.3. Now you can do the same for side B, except you need the angle B. But an easy way to do that is to do 180 minus your given angles, 41 minus 90. And because you already have two angles and the triangle adds up to 180, you know that the missing angle is the right one if it adds up to 180. And if you do that math, it should come out to 49. And if you do all that math, 49 plus 41 is 90, plus 90 is 180. So that's how you know that's correct. Now you can use that angle to solve for side B. So let's do the same thing. You're given 7.4 over your sine 41, your angle. I did this a bit too close, but now you can do side B over angle B, which now we know is 49. And then cross multiply these two and these two. And then when you do that, you should come out to side B is 8.5. Oops. Oh, I'm black. 8.5. And that is question 32. Now you can apply the same to question 33. Let me just erase this right here so you can see. Oh, see. So draw your triangle. One angle is always 90 because it's a right triangle. Let's label that. That just so happens to be C again. Doesn't matter where you place the points. Let's fill in our givens. So side A is 13. Side B is 35. Now we can't exactly jump to this yet because we don't have any full angle and side pairs. However, we can do Pythagorean theorem, which is a squared plus b squared equals c squared, because we have the two side lengths and it's a right triangle. So 35 squared plus 13 squared equals c squared. And when you do that math, you should come out to length C is 37.3. Now that you have that, you can have angle C and side C and match it together to do law of sines. So let's solve for angle A. 37.3 side C over angle C is sine 90 equals A. So we got side A, which is 13, over angle A, which is sine A. So cross multiply. And then when you do this, you're going to do 13 sine 90, divide that by 37.3. And since we're trying to solve for the angle, you're going to have to do second sine, second answer. And that should get you your angle. And if you solve the nearest degree, that's 20 degrees. It's a bit bad. 20 degrees. And if we use that same tactic here's the thing, you could use the same tactic for angle B, but I find it easier to just do what we did over here, adding it up to 180. So let's do 180 minus 20 minus 90. That should get you angle B is 70 degrees. That's how you solve those two. It's pretty straightforward. You don't have to use the law of sines. You can also use SOHCAHTOA up here, which is pretty much just basic math. So you can do opposite over hypotenuse, and that's how you solve for the angles and whatnot. I recommend, I mean, you could do whatever, but I would do this one. I find it a bit easier, but whatever floats your boat. But yeah, that's how you do it.